All right, so we're going to go through the 6-2 notes, and we'll go through the homework from last week. So the title of this section is Matrix Multiplication, Inverses, and Determinants. Lesson objectives. I can multiply matrices, and I can find determinants and inverses of 2x2 and 3x3 matrices. So the first thing we get to before we start the multiplication is we do operations and matrices. So what we have right here is 2x2 matrix addition on this slide. How does that work? Well, if we have, let's say, 1, 2, 3, 4, plus, let's say, 5, 6, 7, 8, we just add the corresponding elements. So 1 and 5 come together to give us 6, 2 and 6 give us 8, 3 plus 7, 10, and then 4 plus 8, 12. So we still end up with a 2x2 matrix. It doesn't change anything. We still end up with a 2x2 matrix. For this idea of scalar multiplication, what happens with that is we can scale the matrix up or down in size, and you can see that here, 7. So we're scaling it up from 3 to 21, -1 to -7, 0 stays 0, and from 5 to 35. Here with 1/2, we're scaling it down, so each of these numbers would be half as big as the original matrix. And with scalar multiplication, we can also utilize a negative number. All right, things get fun when we get here and we talk about multiplying matrices, because we have 3 elements to this slide. We have a picture, right, that takes you through kind of a step-by-step process for how this works. And you say, okay, it's interesting. What does that mean? Then you see this picture with an R by N named B and an N by R named A. And you see these things multiplied together and it looks like a tic-tac-toe grid. What does that mean? Well, when we look at the words over here, matrix multiplication only works if the columns in A match up with the rows of B. If they don't match up, you can't do it. So let's take a look at this right here. So A, so I always say rows and columns because that's how we name our matrices. So we have 2 rows here, 3 columns. So A is a 2x3. Over here for B, we have 2 rows, 3 columns. So we have another 2x3 matrix. Now, if we do AB, then we have a 2x3 times a 2x3. So the columns in A do not match up with columns of B, so that's how we can't do it. What about if we try BA? B is a 2x3 matrix. So is A. Now in this case, because B comes first, the columns in B do not match up with the rows of A. So here we get another, we can't do this. What's going to happen with number 2? Because these 2 problems, clear ink from the page. So this is number 1 on the worksheet from last week, and this right here is number 2. So right here we have a 2 by 3. And here we have a 3 by 2, because once again we call it rows by columns, so the rows are always listed first. All right, so the first thing I want us to take a look at is AB. So if we have a 2 by 3 times a 3 by 2, then our final product, our answer, is going to be a 2 by 2 matrix. All right, so our answer is going to be a 2 by 2. For the second part of this, for B times A, well, B, we said, was a 3 by 2 matrix. A is a 2 by 3. So our answer is going to yield a matrix that's 3 by 3. So that is an I there. So A, B, C, D, E, F, G, H, I. All right, now how do we get there? Okay, so we have -2, 0, and 3. So first off, -2, 0, and 3. That's my first row at A. What I'm going to do is I'm going to combine that with the columns in B. So we have 2, -1, and 9. And I'm going to add those together, right? So that gives us -4 plus 0 plus 27, 23. That goes in the upper left position. Next thing we do is we repeat the rows of A, and we go to the second column of B. So that's going to be the 0, 0, 3. So what does that yield? 0 plus 0 plus 9 is 9. All right, now for our answer, we need C and D. We need this bottom row. How do we get there? Well, we're going to keep our B's. All right, we're going to keep the 2, -1, and 9, and 0, 0, 3. We're going to combine those this time with A's second row. So 5, -7, 1. 5, -7, 1. So that gives us 0 plus 0 plus 3 down in the bottom right. And here in the bottom left, 5 times 2, we get 10. Negative and negative, it's going to be positive 7. 9 times 1 is 9. When we add those together, we get 26. And that's our answer. So a 2 by 3 times a 3 by 2 gives us a final 2 by 2 form for our matrix. Now here, we have a 3 by 2 times a 2 by 3. Ooh. So what's going to happen right there? Well, we're going to come across now, and we're going to take each row in B and multiply that by each column in A. So we're going to have, from B, round over 2, 0. So that's going to be the first row in B. So we'll get our second row for B, -1 and 0, set up. Then we'll get our third row for B set up. 9 and 3. 9 and 3. 9 and 3. Now we're going to come in, and we're going to put in the columns for A. So -2, 5. So -2, 5. 0, -7. And our third column for A was 3, 1. So 3, 1. And we're going to join each pair through the operation of multiplication. So I'm coming here, I'm putting my multiplication symbols in. All right, so here we have 0 plus -4. That's -4. And I'll go ahead now and I'll erase these elements, because this is going to be our first row, our second row, and our third row. So starting off on the first row, we have a -4. So right here, 2 times 0 is 0. 0 plus 0 is 0. Over here, we have 2 times 3 is 6. 0 times 1 is 0. 6 plus 0 is 6. That's our first row. Second row, negative times negative is positive. 5 times 0 is 0. So 2 plus 0 is 2. Right here, anything times 0 is 0. So 0 plus 0 gives us a 0 right there. For our third term, in the second row, -1 times 3 is -3. 0 times 1 is 0. When we add those together, we get -3. For our third row, right here we have -18 plus 15, which gives us -3. Here, 9 times 0, we get 0 plus -21, which is -21. And then for our final term, so we have 9 times 3 is 27, 3 times 1 is 3, 27 plus 3 is 30. And that's our final answer. So our final answer is in the form of a 3 by 3 matrix.